Welcome to homework.
We're told a 150 kilogram electromagnet is at rest and is holding 100 kilograms of scrap steel when the current is turned off and the steel is dropped. Knowing that the cable and the supporting crane have a total stiffness equivalent to a spring constant of 200 kilonewtons per meter, we want to determine their frequency, the amplitude, and the maximum velocity of the resulting motion, the minimum tension that will occur in the cable, and the motion of the magnet 0.03 seconds after the current is turned off. Okay, so we have our spring constant, and we have the mass of the magnet and the mass of the steel scrap. So when it's holding the steel scrap, it's displaced from its equilibrium from when it's not holding it by a value of, well, again, this is just basically equations of equilibrium. Kx0 equals the weight, or so the initial displacement is the additional weight, the mass of the weight of the steel scrap divided by the spring constant, and it is 4.9 millimeters. Now, once the steel scrap is released, then the frequency of the system is square root of K over the mass of the electromagnet, and that is 36.5 radians per second, or 5.81 hertz. Now, we can figure out what the maximum velocity is, because that's just the maximum displacement times the natural frequency, and we know this is going to be the maximum displacement because it's going to start off at zero, or start off at this value and then oscillate back and forth, assuming there's no dissipation. So we have this, and we get 0.179 meters per second. The minimum tension is the tension in the cable at equilibrium minus the tension when the at the maximum, at the peak motion of the electromagnet. So it is, the tension in equilibrium is MAG, and then Kx naught we have from here and here, okay, because the maximum tension will be a plus in here, and that would be just as it, right when it gets released, the tension actually will change from supporting this total mass to just the mass of the magnet, and then when it oscillates back to the top, the tension will be at its minimum, and we get 490.5 newtons. We have the displacement is the initial displacement cosine omega nt, so the velocity is minus x naught omega n sine omega nt, and we can plug in, we know everything here, and we can plug in 0.03 seconds, and we get that the velocity at that time is minus 0.159 meters per second, and that would be up, since we measured displacement is down.